real tricky one. I'm going to come back to this because, as you heard this morning, there's a lot of confusion about causal relationships versus predictive ability of big data, if you will. So as we think about big data, we can think about scientific data, we can think about digital media, we can think about various kinds of sensors, we can think about various kinds of sectors in the economy that have been being transformed through access to various kinds of data. This is one of my favorite slides from Intel Corporation. Let me give them credit for this. That what it shows you in a snapshot is what happens in an internet minute. I'm sure many of you have seen this. To further exemplify this, consider, for example, that what happens in an internet minute, 200 million email messages. This is as of 2012. It's significantly more today. 80,000 sales on, I'm sure it's significantly more than that today. Hundreds of thousands of, as you heard, 500, actually million rather, tweets every day. 20 million photos are being viewed on Flickr and so on. But what's revealing is that if you look at the lower, to your left, I suppose it is, today the number of network devices in 2012 were expected to be roughly the same size as population of Earth. And by 2015, only a couple of years away, that number is expected to double the population of Earth. Think about it for a second. There are a couple of really important points here. One is that all of this data and all of the traffic that we see on our networks is partially catalyzed by access through mobile devices. And the second point is that we're seeing emergence of a number of essentially applications, particularly in social networks area, that probably about 5 years, no more than 10 years old, that are really driving much of the growth that we're seeing. Let me elaborate on that for a moment, and I'll talk about some of the infrastructure issues, policy issues in a moment. There are several factors at play here. One has to do with mobility and how mobility essentially is driving data growth. Let me share with you a couple of things. One is mobile phones are the only digital system that are accessible to the majority of the planet today. Furthermore, mobile devices have eclipsed traditional computers, laptops, and desktops as the point of entry for internet. Consider the following point. 35% of homes today do not have landlines anymore. Furthermore, by 2015, it's expected that wireless web services to exceed wired use in the United States. That's already happening, as it turns out, in Asia Pacific. The second driver of this growth that we're seeing has to do with social media, and you heard a lot about that earlier today. Consider this for a second. How could companies such as Facebook, Twitter, you name it, that provide free services could be worth billions of dollars, rather? This has to do with monetization of course, user data. What we're seeing essentially is not only targeted advertising, detailed profiling of customer behavior, opinion, preferences, and so on, but also how predictive analysis is really transforming some of these approaches to marketing, to business models, and so on. The old way of marketing was you craft a universally attractive message to a large audience. Today what you're seeing is new marketing is you deliver essentially targeted messages to appropriate customers at appropriate time, at appropriate location, for example. And of course, when you look at the data, you see that you heard about 500 million Twitters per day by 250 million active users, but also Facebook today is collecting over 500 million terabytes of user data every day, 500 terabytes of user data. Also, 81% of lawyers that were surveyed a couple of years ago said that they use Facebook as a significant source of evidence. I can't confirm that, but since we're in a law school hosted by law school, I'm sure you can figure out if that can be confirmed. Another source of that has to do with digital media and data exploration. I don't have to tell you how the old kind of media is being transformed, partially through focus on content rather than focus on medium. Something that we haven't talked about much today has to do with how big data and scientific exploration is changing. We're talking about data from telescopes, we're talking about data from particle accelerators, we're talking about genome sequencers, and so on. One example of that, the Sloan Digital Sky Survey, which in 2000 collected more data in its first few weeks than had been collected in the entire history of astronomy. The Large Synoptic Survey Telescope, which is due to go into construction in a year or two and hopefully operational within a few years after that, will collect double that amount every week. That's roughly about 40 terabytes of data. And you see this kind of essentially access to data. And of course, we've all talked about connected sensors, smart everything, and the relationship of that to data. So why not? By the way, I should also highlight that this whole issue, the paradigm shift that we're seeing in scientific discovery from hypothesis-driven to data-driven discovery is happening. It's not a dramatic shift in a sense that we don't do any hypothesis-driven discovery, far from it. But you see an evolution that is truly transformative and is impacting many science disciplines. Now, so why now? And we've talked, someone mentioned today earlier that we've been talking about decision support. We've been talking about OLAP. We've been talking about business intelligence. We've been talking about business analytics for decades. Why now? Why big data now? There's a confluence of social, technical, and policy interests. We've seen decades of advances in technology. We've seen plummeting costs of computation, communication, storage. We have seen consumer technologies, social media, and so on. But also, most importantly, data is no longer regarded as static. It's a new raw material for corporate assets. It's used to create economic value. And it's also a foundation for many, many, many new business models and businesses. And of course, when you look at the platform economy and the innovation ecosystem, it plays an integral role as part of that. There's also another aspect of it that has to do with open government, which I'm sure we'll talk about, and also democratization of tools and data. Now, with that, let me talk about a couple of points about investment from the federal sector and a few challenges. First of all, the PCAS, which is the Presidential Advisors on Science and Technology, data to knowledge to action has tremendous potential to transform all areas of national priority. With that, I'm sure you know that a couple of years ago, we launched a federal big data research and development initiative, which was a White House initiative, which involved just about every imaginable federal agency. National Science Foundation and NIH were the two lead agencies that co-lead the senior steering group in big data. But at the time of that announcement, we had active engagement not only from NSF and NIH, but Department of Defense, DOD, Department of Energy. And since then, there has been a proliferation of essentially investment from various federal agencies, some of them collaborating together, some of them independently, investing in a number of different areas. From NSF's perspective, our framework for investment includes not only foundational research to develop new technologies and techniques to drive essentially knowledge from data, but is also about investment in cyber infrastructure to manage, curate, and serve data to research community. It also focuses on new approaches to education and workforce development. That's been fairly transformative, and I'll say a couple of words about the needs on the education side. And finally, new models for collaboration, new models for bringing computer scientists, statisticians, social scientists, behavioral scientists, the folks from the various science disciplines in physical sciences that collaborate on data to drive new discovery. Now, this, of course, leads to some complex policy settings. Researchers want data. Now, let me just speak from a perspective of purely from a research community's perspective. Researchers want data. Public policy requires access to data. Public policy also requires protection of privacy, intellectual property, and sensitive information. Finally, new business models challenge publishers and societies, and I'm sure you know about the White House memo on 22nd of February of 2013, access of results from federally funded research, both for data as well as publications. That's an ongoing thing. It will require significant investment. Let me talk about a couple of issues. A couple of weeks ago, I was at Borders. I'm sorry, not Borders, Barnes & Nobles. My apologies. It was not intended. It was not. So I was at Barnes & Nobles, and I started looking at books that focus on technology and talk about transformative impact of data and technology. And here's what I came up with. I don't know if you can see this in the back or not. Let me read a few titles to you. Infinite Progress, How the Internet and Technology Will End Ignorance, Disease, Poverty, Hunger, War. The End of Big, How the Internet Makes David the New Goliath. If any of you have written these books or authors, my apologies ahead of time. Predictive Analytics, The Power to Predict Who Will Click, Buy, Lie, or Die. The New Digital Age, Reshaping the Future of People, Nation, and Business, and this is by Eric Schmidt, chairman of Google. Smarter Than You Think, this is one of my favorite, How Technology is Changing Our Minds for the Better, and right next to that was Mind